Welcome everyone. So guys, today we will start the routing. So again guys, we start the routing from the scratch. The first guys, we will cover the static routing. Okay, so guys, इस topology में you see we will provide the reachability from this machine to this public IP through a static routing. Okay, you see guys, routing is very important. Okay, so we will see how we configure the forward routing as well as the reverse routing. Then definitely guys, mainly we after that static routing will cover the ISP failover. So we see guys, how we can achieve the ISP failover with static routing. And the later on guys, when we cover the BGP, so in dynamic guys, it's very easy. However guys, when we're doing the static routing, so we see with by default static routing is unreliable routing. So normally guys, in the real world, when you specially configure the static default route towards the ISP, we always use IPSLA. Okay. Then definitely guys, in the dynamic routing, we will cover OSPF and BGP protocol. So we will see the scenario the issues or the scenario-based questions and the scenario-based requirement. So mainly guys, we'll focus on the OSPF and BGP. Okay. And again guys, I'm not covering those protocol fully. So my main purpose is guys, in the live classes, I will discuss the interview questions, troubleshooting scenario, and the requirement. However, guys, I already provide you my CCNP video or BGP video. Okay. So if you want the whole BGP, then you can guys watch my recorded video. Okay. And the next thing, guys, we also cover the VRF, virtual routing forwarding. So basically, this basically allow you to create the multiple routing table. So this will we will see definitely in more detail how people are using now. Okay, especially over the VPN. So we'll see in case why we create VRF, or in case if you want to do the route leaking. Okay, let me give you one example. Okay, how people are designing the network. You see guys, generally this is, let's say this is my internet and this is my data center. Okay, and the rest of side guys, we have a spoke location. So every spoke location guys, they are connected to the data center via the VPN. Okay, and generally guys, these days, earlier they mostly use DMVPN, and now people are moving to guys SG-WAN. Okay, so the idea is guys, definitely we'll cover all these band technology in this course. Okay, but you see guys, generally, let's say we have a router on a spoke location. Okay, and this interface we are going to the LAN. So this is an interface where we have terminate our internet link. So this internet basically guys, providing the transport to the DC side for configuring the VPN. Okay, so generally guys, what we do, okay, we put this interface in VRFA, and the terminal interface we also point to the same VRFA. So all the traffic from the spoke location, okay, it come to this LAN interface, and everything guys, your default would pointer to the DC side. Okay, the reason guys, mainly guys, they install the firewall, or maybe let's say you have a proxy server. All the firewall, they are located on your data center side. That means guys, whatever the filtering you require, okay, you will configure on the data center firewall. And all the spoke location, okay, they are sending the traffic for an internet to first your DC. Then on the DC side, you have a firewall, and then you are basically providing the limited internet access, okay, through the firewall. So this is normally you will see the design. Okay, and this interface where we have internet connection, okay, this is basically participating in the global routing table. Okay. And in case guys, I have seen, let's say all the traffic coming to my this interface, LAN interface, which is participating in VRFA. Let's say guys, if you have some requirement, you want let's say this is my website, okay, abc.com. And for this website, I don't want to send the traffic to the data center. I want to send the traffic directly to my local internet. Okay. So this is again known as a breakout, or in Cisco SD-WAN, this is known as DIA, direct internet access. Because like I have seen like in the real world, some of the website, they only work if you're using your local public IP. Let's say like I've seen like, let's say guys, your data center in Singapore and you're this location in India. Some of the Indian government website, okay, they only work if you're using the public IP of Indian region, okay. So might be like you get the requirement. So in this case, like you see, so traffic is coming to VRF A, but instead of using the VRF routing table A, you want to use the default routing table. This is known as VRF leaking, okay. So definitely guys, like we will see this couple of the complex design, okay, in case if you want to move the traffic from one VRF to another VRF, what are the way, okay. So the multiple way, guys, this is like the interview question as well as the real requirement, okay. Then we will cover the WAN technology. So as I show you how we connect to the site, okay. So mainly by we using the VPN. So I start with the GRE, IPsec. We'll also see the DMVPN. But for SD-WAN, guys, we mainly focus on the theoretical part and why we use SD-WAN. And the idea is, guys, like I cannot show you this through by the practical, but in case, guys, like as you already working, if someone already working on this technology, you can share your screen and I can explain about the SD-WAN on the live network, okay. So right now, guys, I don't have access to share the screen, but if any one of you working on this SD-WAN technology, and if you are okay to share the screen during the class, I will explain you, okay. I will explain you. But again, the purpose, guys, like I will cover the theory part. And so at least, guys, like you can mention this SD-WAN in your CV. And I believe like guys, like after you go through my PPT, okay, you will like capable to give the answer, okay, especially like because they will in the interview they will basically ask you the basic question, okay, what is SD-WAN and how it work, okay. So yeah, so we see like this is the agenda of this routing classes, guys. And mainly, guys, like as I told you, all my full videos, CCNP routing and BGP OSPF, I believe like those who already paid the fees, those already get my full video, okay. So let's start the today class. So in the first class, guys, like if you see this diagram, we will provide the reachability, okay. So from this PC to this destination, okay, we will provide the reachability. And so far, guys, like I have only configured the IP addresses and I have configured the routing, okay. So if you see the hop by hop IP addresses, so this is my PC in VLAN 1. So we have a 2-core switches. So here, guys, like I have configured the HSRP, and for VLAN 1, this device working as an active device, okay. So we have a virtual IPs 100 and 253, my physical IP, okay. So that means this device first send the request to this device to our core 1. So core 1, guys, like they don't have any routing configure. So we, as I told you, I only configure the IP addresses. Then we will do the, in this case, guys, like as we are providing the internet access, for the internet access, we use default routing. But in this case, guys, like we're using static routing. So we'll point the default route towards the router. And this router, we have ISP1 connection, okay. So on this router, again, we'll do the static default route towards the ISP, okay. So this is how the routing design should be in this network, okay, to provide the reachability from this PC to this public IP, okay, 8.8.8. So let me show you guys, like right now, as I told you, I haven't configured any routing, okay. But if you see this error code, okay, like generally, guys, like we check the reachability through via ping. And when you ping the destination, you will see like these error code, okay? Like sometime you will see request timeout, and sometime you will see the error like a reply from the IP address and destination host unreachable. And sometime like you will see the TTL expire, okay? And if you get the reply, that means you have a reachability. But let's understand this error message, okay? Because based on this error message, you can figure out what is the issue, okay? So right now, like if you go to the PC, and on this PC, guys, if you see, I have configured the IP address and the default gateway, okay? So if you see IP config, so IP address is configured, default gateway is configured. That means on the PC, as I told you, like every device, okay, they do the routing. This PC, like once you define the gateway, which is 1.100, it will automatically do the default route towards to the gateway IP side, okay? So in this case, guys, like if you see any different network, okay, like if you want to communicate 8.8.8, and right now, if you see the error code, okay, reply from this device, which is our core one, and destination host unreachable. So based on this error, okay, guys, similarly, like we are sending the request to this device, okay, which is 1.253, and they are replying back destination host unreachable. This means, guys, like the issue on this device, okay. So in this case, guys, like if you see this error, you directly log into this device and check the routing table of this device. So this means, guys, like destination host unreachable. Even this device don't know how to reach this destination, okay, 8.8.8. Because like you see, like as I told you, I haven't configured the routing. So if you check the routing table of this device, even this device don't know how to send the traffic to this 8.8.8. So let's do the routing, guys. And I will do the static routing. So the way, guys, like we'll configure the static routing on a core. So if you see the routing table, show IP route, I don't have any route, okay? So we only know C means connected and L means local IP, okay? So local IP means that is the /32 IP, which we assign to the interface. And this is the directly connected subnet, okay? And right now, this device don't have any gateway set. So gateway, guys, like only will be set, okay, like once we configure the default route. So for the internet, guys, like as we know, we always use the default routing because the internet is unknown destination. We don't know the exact IP of Google, Yahoo. So we always point the route, IP route 0.0.0, and we will point the next stop IP. So in this case, the next stop IP will be our router, okay, which is R1. So I'm pointing 10.1.1. So this is a one way you've seen, like we configure the static routing. But there is the other way, okay, which is the, I believe, the best way. Instead of defining the next stop IP, okay, always you use the static routing like this, okay, like IP route 0.0.0, 0.0.0. Also define the leaving interface. In this case, the leaving interface is by SBI interface 100 and the next stop IP. So the benefit, guys, configuring this way, static routing, okay. So you see, like I also define my leaving interface and my next stop IP, okay. So this is basically, guys, like avoiding the extra lookup. So if you do the routing, static routing only with the next stop, okay, this will basically do the recursive routing. Because routing basically generally, what is routing, okay? If the traffic is coming to this interface and leaving to this interface, and the leaving interface decided by your routing table. So this is the main thing, okay? Like routing is what they require the leaving interface, okay? To find the leaving interface, if you only define the next stop IP, okay, this will basically further, they will check the another lookup to find the leaving interface. So that's why, guys, like this is the best way, okay, do the routing. And we always, the other way, like some people, they use a leaving interface, that is also wrong, okay? So make sure, guys, like when you're using the static routing, okay, always define both leaving interface as well as the next stop IP. And if you want to study this in more detail, okay, guys, like if you watch my CCNP video, you will get more idea about this, okay, like why I'm using these two. But let me give you the brief idea, okay, like let's say if you're doing the static routing, show IPsec. So this is a guys an actual table, okay, which the router use to send the data plan traffic, okay, show IPsec. So if you see show IPsec 0.0.0 detail, right now, show IP route, like if you see guys, like I have two default route, okay. One is without leaving interface and other is with leaving interface, okay. So let me guys like point some other route, okay. Let's say IP route 192.168, let's say 20.0.255.255, and the next stop IP is 10.1.1. So this is the static route. We are only pointing the next stop IP. If you see show IP route 192.168.20.10, so if you see guys, like if this device want to reach this destination IP, so the routing table entry match to this subnet, and my next stop IP is 10.1.1. But still this router don't know what is my leaving interface, okay. So in this case, guys, like the router again do the another lookup, and this lookup basically guys like tell you my leaving interface. So if you see guys like show IP SAP, in the SAP guys, this will give you the detail. To reach this destination IP, we will do basically a recursive lookup, okay. So recursive lookup basically is nothing, basically you are checking the routing table more than one time. So let me now show you the another example where you're defining the leaving interface as well as next stop IP, okay. So if you let's say do the routing which I show you, okay, the best way, which is 192.168.30.0.255.255, and the next my leaving interface is 100, and my next stop IP is 10.1.1. So now guys, same thing guys, like if you see show IP SAP for this destination IP 192.168.30.100 and detail, if you see guys, to reach this destination, we only look the routing table at once, okay. So this to reach this destination, we don't need to do the recursive lookup. That's why guys like always use the static routing, okay, this way, okay. So on the core, we have configured the default route, okay, which is towards to our router one. Then on the router one, again, we don't have configure any routing. Show IP route. The show IP route, they only know about the connector network as well as the local IP. So on the router one, again, we will do IP route 0.0.0, and the next stop IP will be our ISP IP, which is 1.1.1. So again, like we always have a habit to configure the static routing by only giving the next stop IP. I have seen like even I'm not using the best way, which is basically defining the leaving interface as the next stop IP. But yeah, I seen in my existing organization, okay, my manager is very technical, okay. So he here like I have seen like every static route, okay, they are using with the next stop IP as well as the leaving interface, okay. So yeah, so you see guys, like so far we have done the routing. So if you see guys, like the routing hop by hop, this PC now send the traffic to core, and the core has the default route pointer to the router one, and the router one have the default route towards to the ISP. So if you see the guys now ping response, okay, let's say guys on the PC, if we see the ping response to the same destination 8.8.8, so this time guys like you will see the different error, okay. And this time guys like the error is request timeout, which is also known as RTO. So you see like every by default, this window machine, this sends the 4 ping packet. And when we send this echo request, so we will wait for 2 seconds, okay? Within 2 seconds, if we don't see any reply, we will consider this packet RTO, request timeout. The request timeout means no one sending us the reply back. So in this case, guys, like if you see the routing we have configured the routing only the forward routing, not the reverse routing, okay? So the reason, guys, like we are seeing this RTO message, so we are sending the request to core 1, core is sending the request to the router 1, then the router 1 is sending the request to the ISP, but when the ISP sending the reply back, which is your echo request, okay, the source become 8.8.8 and the destination become 192.168.1.1. So in this case, guys, like if you see this device, check the routing table, how to reach 192.168.1.1. So on this device, guys, like we haven't configured any routing. So this device don't know how to go back, okay? That's why, guys, like basically they are not sending any packet, okay? And this PC earlier, if you see, we sending the request to the core 1 and core is replying back to us because core know how to reach this machine, okay? But now ISP don't know how to reach this machine, okay? That's why, guys, like we are not getting any response, and we will consider this as a RTO, which is request timeout, okay? So if I show you, guys, like on the ISP side, if we see debug IP packet, let's say detail, when we're sending the packet, ISP got the request, but ISP, guys, basically it will show you. So if you see, guys, like ISP when receive the packet, they are saying source is this, destination is this, and when we replying, we don't have the routing table, okay? So routing is failed, or sometimes I have seen showing packet is unroutable, okay? But that's the main thing, okay? Basically, if you see this the device, the routing table of this device don't know how to go back, okay? So this is basically the issue with the, we can say like in the real world, reverse routing. So right now, guys, like if you see this device have a default route, okay? I believe, guys, they are sending the traffic to the this device, okay? So in this case, guys, like if you see to provide the reachability end to end, we also configure the reverse routing on the ISP for my LAN subnet, okay? Normally, guys, like we never do the ISP never do the routing for your LAN subnet. Generally, guys, like we will use either NAT on a router or on a firewall, okay? So we always send the traffic to the ISP with our public IP, okay? So source IP will be always our public IP. We never send the actual our LAN IP because this is a private IP address, guys. We never send the private IP while communicating to the public network. We always use NAT, network address translation, okay? So here, guys, like I'm not using any NAT. So to provide the reachability end to end, okay, we also need to do the routing for ISP on the ISP router to my router 1. Then the router 1 do the routing on a core 1, and the core 1, guy, like already know because this is a directly connected network, okay? So this is the reverse routing, okay? And once we configure the reverse routing, so my forward routing is configured, my reverse routing is configured, then we should have a reachability, okay? If you remember, guys, like one of my previous student, okay, like previous classes, they made a topology and they were discussing like they are not able to reach the internet, and we found the issue was with the reverse routing, okay? So that's why, guys, like you see routing is very important, okay, because it is basically providing the reachability. Lot of your issue, okay, that is because of the routing, okay, even on the firewall also. So Hope guys, make sure your forward routing is correct and your reverse routing is correct. Okay. So in this case, guys, like I'm doing the routing. Okay. I'm doing the reverse routing. So on the ISP router, we'll define if you want to reach 192.168, just forward the traffic to router 1. Okay. So 255.255, and the next stop IP is 1.2. Then on the router 1, we will say IP route 192.168, 1.0, 255.255. The next stop IP will be the core IP, which is 10.1. I believe, let me check the core IP. Show IP interface brief, which is 1.2. Okay. Yeah. So now, guys, like we have configured the forward routing as well as the reverse routing. Now, again, if we check the connectivity now, so we should have a ping. Okay. Yeah. Now you can see like we can ping the 8.8.8 IP. So this is basically how the routing works, guys. So make sure, hope your routing should be correct, and make sure for the reverse path, you have configured the proper routing. Okay. So any question, guys, like up to this point? Any question up to this point?
Hey, hi, good day.
Yeah, hi, Rahul.
Okay, so I was having two more questions. So right now we have seen how can the request timeout issue occur, right? One more we have seen is destination host unreachable. Now two more messages will be given in ICMP, like destination network unreachable and destination port unreachable. So can you please explain these two messages also?
Okay, the destination net unreachable. Okay, this is because of, let's say, in middle, some of guys blocking the ICMP traffic. So let me show you guys like why net unreachable. Okay, which is, let's say, on a core 1, I have one ACL show IP access list, and let's say this access list. Okay, this access list basically only allowing the port 80, 443, and HSRP port. So I like your ping work on under the ICMP protocol. So ping use ICMP. Okay. So let's say like I'm applying this ACL, which is basically blocking the ICMP traffic. Let's say IP interface VLAN 1 IP access group, the ACL name inbound. Once we apply the filtering, okay, in our network, now if you try to ping 8.8.8 from the end machine, now you see the destination net unreachable. Okay, but this is only the case with the router. Normally, like if we configure the restriction on the firewall, so normally like what router do? Okay, like once you configure the ACL, so we are sending the echo request. When traffic is hit to this interface, okay, which is VLAN 1, they see there is one ACL. Okay, so ACL, like if you see, they are saying the reply from this device, which is our core switch. And if you see the error, destination net unreachable, that means this device is doing some filtering. Okay. But in the real world, we use firewall for allowing or denying the traffic. Firewall, guys, like when the firewall doing the filtering, okay, they will never tell you, like from the end machine, let's say if we're sending the ICMP packet to the firewall and the firewall coming in the middle, and if they're dropping the traffic, they will never send the back message to the machine. Okay. But router, guy, like they always sending the back message to the machine, which basically like from the attacker perspective, okay, now they know which device is doing filtering, this device. Okay. But firewall basically drop the packet silently, so they will never respond back to the end machine. But this is the one reason, guy, like if you see the destination net unreachable, which is basically like this device is doing some ICMP restriction. Okay.
Yeah, so the reason behind this is, in case there is firewall in the network, it will be dropping packets silently and we'll be getting RTOs, not destination unreachable,
right.
Okay.
So as I told you, like if you're not getting any response back, you will consider this RTO. Okay. And generally, like this error, like I have seen like earlier, but as I told you, we always use firewall, okay, in the real world for the packet filtering or ACL, okay, or on FortiGate or Polo we call policies. And generally, like we only allow the application port. For the end user, we never allow the ping, okay. Ping is only used like in case if you're doing the slowness issue, only just for temporary allow, okay, for troubleshooting the slowness issue. But like later on, like when we cover the firewall, I will show you. We get the ticket. In the ticket, they mention the application port number, and we only allow the application port number, okay, not the ICMP traffic. What is the other message you were?
One more scenario about destination port unreachable.
Destination port unreachable. I believe that is regarding the trace route, okay, because destination port.
Yeah, in trace route, in case if the trace is using some UDP port, it will be giving us UDP port number unreachable.
Right. That is only like because this window machine, okay, when you're doing the trace route from the end machine, they don't use UDP port, okay. However, the other device, like if you're doing the trace
Linux machines will be using.
Yeah. If you're doing the trace route from the router is for, if you do the trace route from the router, they also use UDP. And if the Linux machine, they don't also use the ICMP. Yeah, the point is, if you're seeing this port unreachable, that means there is some restriction. There is some restriction which are dropping your packet, okay, UDP packet.
Okay. And how like how do we perform TCP trace route?
TCP trace route, again, as I told you, we will use that the way we check the connectivity, okay, like one way, let's say you have a issue, okay, you have an issue from this source.
Because the thing is, let's say
I got your point.
There is a firewall in network and they have denied ICMP.
I got your point. Let's say this is your destination IP and this is working on a port 80, okay. The one way, simply like as I told you earlier also, the way we test the connectivity, okay, from source to destination, we always use the telnet command. So telnet, so this is not a correct CMD. Yeah, telnet and A.A.8 and the port number 80. So this is the way like we check the connectivity end to end. So we always, like, let's say this is your TCP application, HTTP, which use the port 80. So we'll see like always the telnet and the destination IP and the destination port. So as I told you, ping is blocked, and ping is only for up to a layer 3, okay. So this step, the telnet, destination IP and destination port, this is basically, guys, we are checking the connectivity above layer 3, which is basically layer 4, okay. So if you see connection is established or open, that means your TCP port is open 80 end to end, okay. If there is a firewall, the firewall is basically allowing this port, okay, port 80. This is basically we do the testing for TCP application. For UDP, guys, like you cannot test this via this telnet command, okay. Telnet command only help with the TCP application, not for the UDP. So if you want to check the UDP also,
so when we use this telnet command, let's say there is reachability until my ISP, only the telnet is not enabled.
Rahul, like we will see this thing, okay, later on, like when we talk about the troubleshooting, okay, this But yeah, anyway, like if you want, yeah, because I have like when we covering the firewall, I will explain you a scenario where telnet is happening, but still your application is not working. And if telnet is not happening, how you figure out is this your network issue or the issue of the server side, okay, or the application side. So we later on, like Rahul, yeah, we will cover this thing, okay.
Okay.
Yeah. Any other question? Really?
Please explain UDP. Just now you were explaining and stuck.
The UDP, like for if you want to check the UDP connectivity, there is software, okay, which is port query. So this is also interview question, okay. If we want to check the connectivity end to end, okay, and that connectivity is basically application is using UDP, how we can check, because telnet is only, as I told you, through telnet we can only test the TCP application, not the UDP. So there is one software which is port query. You need to install that software on your laptop or maybe on the machine, which machine is facing the issue. You can like simply say this is the port is UDP and this is port number and this is the destination IP. Then you will see, you will get the response back, okay, on this software, okay, and they will tell you like end-to-end UDP port is open or not. Port query, okay, that is a tool. So the point is port query is a software you need to install on your laptop, okay. Any other question, guys?
Yeah, I go with. I faced this question. How the trace route works means it's using the ICMP protocols and means when it send one packets, it using the TTL value 1, right?
Right. So ICMP, guys, like if you see, let me, yeah, I got your point. You question is like how a trace would work. Okay, this is normally the interview question, right?
Yeah.
Is this your question, right? Yeah. If you see, guys, like basically like hop by hop, it will basically incrementing the TTL value. So trace route work images. So this is basically like the trace route work. Okay, so hop by hop basically, guys, like this TTL value. So first time, guys, basically they use the one TTL value and figure out this device next to a IP. Then second time they increase the second TTL value, they will get the trace in the trace path, the second host IP. Then they will hop by hop. So the hop by hop basically they increase the TTL value until they don't reach the actual destination. So that's why, like if you see the trace path, we will see the first hop IP address, then the second hop IP, third hop IP. So this is how the trace would work. Okay.
And so, it uses ICMP only.
If you're doing the trace route from the window machine, okay, yeah, it uses ICMP.
Okay, and from Linux machine.
Linux machine and even the router, they use UDP port. They use different transport. Yes.
Oh, okay, got it.
Any question, guys? So yeah, the other error code, guys, like if you see this TTL expire, this is, guys, like generally you've seen, especially when you're doing the static routing. If you have a loop in your network, so like if you're trying to ping 8.8.8 and you have a routing loop, generally, guys, like if you're using the dynamic routing never, you don't have a loop, okay, when you're configuring the dynamic routing. But in static routing, if you, let's say, configure the wrong routing, static routing, yeah, it can cause the routing loop, okay. So let me show you, guys, like let's say on this device, on a core one, we have configured the default route to the router one. And let's say on the router one, we are saying to reach 8.8.8, maybe I have a, let's say, route is pointed to back to core one, okay. 8.8.8, 255, 255, 255, and the next top IP is 10.1.2. So if you see the routing now, so how the basically, like if this PC want to reach 8.8.8, the request goes to core one. Core one have the default route. The default route basically sent to the traffic router one. The router one has the specific route towards to the core back. Okay. So this is basically like we have a traffic loop, and when you have a traffic loop, and if you see the error code, you will see the error code TTL expire. Okay. So let me show you guys like this thing. Okay. Like if you check the ping response from the end machine. So on the PC, if we do, let's say ping 8.8.8, okay, this is basically guys like because of the ACL. Before like occurring the routing loop, okay, our packet is being dropped via this ACL, okay, which is configured on a core one. Let me remove the ACL, okay. So show run interface VLAN 1 interface VLAN 1 no IP access group. And once we remove this ACL, now if we try to ping again, if you see now TTL expire in transit and reply from 10.1.1.1. So something is wrong with this device, okay, router 1. And you can simply do the trace route by like trace RT -D 8.8.8. And you can see guys like we have a now loop, okay. So we are sending the request 10.1.1.1. The router 1 sending the back request to core 1, then core 1 again sending the router 1. So we have a loop, okay. So TTL expire, that means your packet is basically being looped for the layer 3 perspective. Again, the layer 3 loop is not a making the big trouble, okay, because you see like when the TTL value becomes 0, it basically drop the traffic, okay. The only thing I like this layer 3 header, okay, they have a TTL value, but in the layer 2 header, we don't have any TTL value. That's why layer 2 are very dangerous, okay. It will basically make your network completely down. But routing loop, okay, that's not a big issue, okay. But because eventually your packet is being dropped automatically, okay, when your TTL value becomes 0. Okay. And it only like happen because of a static routing. If accidentally you point the wrong routing, like the way I have configured this, so it will cause a looping, okay. Any question, guys? Okay. Now moving to the next advanced, yeah, question, guys.
Yeah, so Gurpreet, like RTO error we get when we don't have bidirectional routing for source
No,
to
Prashant,
destination and destination.
RTO we get like when we don't get any back response.
Okay, apply that.
Yeah, reply packet. Let's say in middle, let's say firewall blocking the ICMP traffic, firewall never responds the end machine. Okay, hey, I'm doing the filtering in the network. Okay, in that case, even that's not a issue with the bidirectional routing. Okay, that's basically the firewall in middle. They are only dropping the ICMP traffic, and however maybe your application is working fine. So in that case, you will also get the RTO. But the point is, RTO you will get when no one is responding you back.
Okay, okay.
Yeah, I'm having one question. You explained that trace route working, right? You said that in the Windows, I guess it takes ICMP protocol, and in
Right.
Linux it takes UDP. Actually, I didn't got that point.
So yeah, you see like let's say like in the Linux, okay, I've seen like trace route. Even though if you allow the UDP, sometimes trace route is not working in Unix. Okay, I believe like some app or you need to install to work the trace route properly on the Linux machine. Okay, but let me show you. Let's say on the router, if I'm doing the trace route. Okay, so the point is like we are checking the trace route from the router itself. Okay, so if you do the trace route on a router, let's say I'm sitting on a router 1 and I'm saying trace route to 8.8.8, and if you see this trace route, okay, which is working on a router, this is used UDP transport, some UDP random port, okay. And the same thing on Windows machine. On the Windows machine, I'm using the trace route 2-8. So this is the way on window we do the trace route, which is the command is trace RT. So here, the point is, this is a different operating system. This is a different operating system, okay. You are using the same thing, okay, trace route, but on this operating system, this trace route use the protocol ICMP. So the point is, let's say if you have any middle device who is doing the filtering, let's say ACL or a firewall, and you want to allow the trace route from the window machine. So you see, like on the firewall or maybe on the router ACL, we are allowing the one ACL entry, and in the ACL entry, we need to define ICMP, okay. So we say like IP access list, permit ICMP, source IP is this, destination IP is this, 8.8.8. So this basically, this ICMP, if you allow the ICMP protocol for this end machine, that means this PC can also ping the 8.8.8 and also trace route the 8.8.8. However, let's say from the same thing, like we have a router. On a router, if we do 8.8.8, so you only allow the ICMP, okay. So ICMP only, that means for this PC, if you do the trace out, you will get the output. On the router, as the router is using the different transport to basically doing the trace out, which is UDP, okay, and you haven't allowed the UDP port, maybe on the router, when you're doing the trace route to 8.8.8, you won't get the desired result, okay. You need to know like which application working on which transport, and based on transport, okay, you will allow, let's say if you have any device doing the filtering, you will allow those protocol, okay. Clear or not?
Yeah. Yes.
I just wanted to add on one more thing, Jayashree. I'm having a suggestion for you. You can go and Google how trace route is performed on Mac OS, how trace route is performed on Windows and Linux. So you will get the difference and mechanism how trace will work.
Okay. Thank you.
Any other question, guys? Okay, let's take the break of 10 minutes, okay? Then we will see the more advanced thing, okay, in routing. Again, guys, like today we will mainly focus on the static routing, but yeah. So let's take the break, take a break of 10 minutes, okay? Then we'll start the class exact 10 p.m., okay?